Now let's move on to what most of the rest of the course is going to look like, evaluating integrals. For this, we're going to use the second fundamental theorem of calculus. We have the integral from 0 to 1 of the quantity of 1 minus 8v cubed plus 16v to the 7th dv. The parentheses are not just suggested, they are required because I have this integrand times the differential dv. And remember what the second fundamental theorem of calculus says. It says I need to find an antiderivative and then evaluate. So first we're going to find the antiderivative. Using the power rule, the antiderivative with respect to v of 1 is v. And then again, the power rule says for 8v cubed, I'm going to, I put a plus, it should be minus, 8v cubed. I'm going to add 1 to the exponent to get v to the 4th, and then divide 8 by that 4 and get a 2. For the plus 16v to the 7th, I'm going to add 1 to the exponent to get v to the 8th, divide by that 8, and then I have 16 over 8 is going to give me 2. That's our antiderivative. You know what, I'll put a plus c in here. This is the only time you'll see me do this for a definite integral. And you'll see why in just a second. We need to deal with the fact that we have limits from 0 to 1. First off, notationally, I'm going to put a vertical line here, a 0 at the bottom and a 1 at the top. That's how I indicate that I'm evaluating all of this from 0 to 1. But this notation here would imply that I'm only evaluating c from 0 to 1. I want it to apply to the whole thing. So I need to open with a parenthesis. And then the vertical line acts like closing a grouping symbol. Now the fundamental theorem of calculus part 2 says put 1 in place of v for all of these, and then subtract what happens when I put 0 in place of v for all of these. Now you can see every single time that c is going to subtract out. Evaluating at 0, well, that's going to be 0. 1 minus 2 plus 2, the whole thing has an answer of 1. Next up, we have the integral from 0 to 4 of the quantity of 4 minus t times the square root of t dt. Now we don't have a product rule for integrating in the same way we have a product rule for differentiating. So I need to simplify by multiplying inside the integrand. That's what this thing is called, by the way, an integrand. Kind of like in a radical you have a radicand, and when you're dividing you have a dividend. Okay, so I'm going to distribute the square root of t into the 4 minus t. I'm going to write it as 4t to the 1/2 minus t to the 3/2 because I'm going to use the power rule. And according to the power rule here, t to the 1/2 becomes t to the 3/2. I already had a 4, and then dividing by the new exponent, 2/3 there, minus t to the 5/2 dividing by the exponent gives me a coefficient of 2/5. Open parentheses, vertical line I'm evaluating from 0 to 4. I end up with 64 over 3 minus 64 over 5. I could get a calculator, but if I use my algebra skills, then I can multiply the first fraction by 5 over 5 and the second fraction by 3 over 3 to get common denominators, but I'm still not going to multiply it out. What I have is like 5 times 64 minus 3 times 64 over 15. I'm treating the 64 like it's a variable. 5 of them minus 3 of them is 2 of them. 2 64s is 128, so we're able to do that without even using a calculator. Finally, we have the integral from pi over 4 to pi over 3 of the cosecant squared of theta d theta. Recall that the derivative with, I'm going to give it to you the way I actually think of this. The derivative with respect to x of the tangent of x is equal to the secant squared of x. So that helps me remember that the derivative with respect to x of the cotangent of x is equal to the negative cosecant squared of x. Remember, trig functions that start with c have derivatives that are negative. And so the antiderivative of the cosecant squared of x, or I should say if f of x, lowercase, is the cosecant squared of x, then uppercase f of x is equal to the negative cotangent of x. So this is negative cotangent of x evaluated from pi over 4 to pi over 3. I'm not opening with parentheses because I only have one term in the cotangent of x. I don't know the cotangent of pi over 3 off the top of my head. I know, it's embarrassing. So I go to the unit circle. Pi over 3 is associated with like 60 degrees there. And I know, I can see here that x is smaller than y. So this point on the unit circle has coordinates 1/2 square root of 3 over 2. Tangent is sine over cosine, so cotangent is cosine over sine. So we're looking at 1 over the square root of 3 because the 2's divide out. Folks, that is literally how I think about all this stuff. Minus, because of the fundamental theorem of calculus, a negative because we have negative cotangent of x. And the cotangent of pi over 4, that one I do know, it's going to be 1. I'll rewrite this as 1 minus 1 over the square root of 3 and be done with it.